Hello all. So this video explains how to do the first question of the first classical mechanics homework. So part A of this question asks you to write out the Taylor expansions for both cosine of omega t and sine of omega t. So we will start by simply writing down what the Taylor expansions are for cosine of x and sine of x. So these are things you can simply look up online or in a calculus textbook. So moving forward from here, since we want to write down the expansions for cosine of omega t and sine of omega t, if given these expressions, I simply let x equal omega t. And from here, I can say that cosine of omega t is equal to the sum from n equals 0 to infinity of -1 to the n, and this is just simply an alternating plus or minus sign, times omega t to the 2n. So for cosine, we only care about the even powers, divided by 2n factorial. Now for the later parts of this problem, it will be helpful if we write out the first few terms of the sum. So for cosine, that would be 1 minus omega t squared over 2 factorial plus omega t to the 4th over 4 factorial plus so on. And a very similar process for sine. We can say that the sine of omega t is equal to the sum from 0 to infinity of -1 to the n times omega t. Here we only care about the odd power, so it'll be 2n plus 1 over 2n plus 1 factorial. And likewise, it's going to be helpful to write out the first few terms of this sum as well. So that will give us omega t minus omega t cubed over 3 factorial plus omega t to the 5th over 5 factorial plus so on. So that's part A. Part B is very similar. B wants you to write out the Taylor expansion for I omega t. So looking up the Taylor expansion for e to the x, we find that's just going to be the sum from n equals 0 to infinity of x to the n over n factorial. So following a similar process to what we did for part A, we're going to say x is equal to the argument of the exponential, so I omega t. And then from there, we can write that e to the I omega t is equal to the sum from n equals 0 to infinity of I omega t to the n over n factorial. And likewise, it may be helpful to write out the first few terms here as well. So we end up with 1 plus I omega t plus I omega t squared over 2 factorial plus I omega t cubed over 3 factorial plus I omega t to the 4th over 4 factorial plus all other terms. And so that's really all we need for B. Part C is a little more complicated, but it's not too bad once we have parts A and B done. So for part C, it wants us to prove the following identity that you'll use a lot in this class. And so that is that the exponential of I omega t can be written as the cosine of omega t plus I sine of omega t. So in order to solve this, let's first remember a relationship of I, which is that I squared is -1. And this is because the definition of I is the square root of -1. So starting from what we derived in part B, let's write down e to the I omega t as 1 plus I omega t plus I omega t squared over 2 factorial plus I omega t cubed over 3 factorial plus other terms. Now I want to simplify this and see if I can get it to look like cosine plus a sine. So first, for the 1, I can't really do anything, so I'll just leave it as a 1. For the I omega t term, I'm just going to use parentheses to separate the omega t from the I, but that doesn't really change the term at all. I'm just grouping 2 of the variables together. For the next term, I'm going to likewise just group the omega t together, but this time there's a squared over 2 factorial. And I'm going to take the I squared out in front. And then I'm going to do the same thing for this term. So I'll take I to the cubed out in front, leave the omega t squared in the parentheses, and then have a over 3 factorial plus other terms. So now I'm going to go through and use that identity that I wrote down at the beginning, that I squared is equal to -1. So that doesn't change the first 2 terms. But for the third term here, we have I squared, so I can rewrite that as -1. Nothing else really changes here. And then for this term, I can rewrite I to the cubed as I times I squared. And since I squared is -1, I can rewrite this as -1 times I times omega t cubed over 3 factorial. And then I can go back through and I can convert all these -1s to just a minus sign. Because that's really all a minus sign is just times -1. Okay, so what I have here is a 1 and a minus omega t to the 2 factorial. And so that looks a whole lot like these first 2 terms of my cosine expansion from up here. I also have an omega t minus omega t cubed over 3 factorial. And that looks a whole lot like these first 2 terms up here. So all I'm going to do now is group those together. So I'm going to have 1 minus omega t squared over 2 factorial grouped together. And so that doesn't change anything because since all these terms are added together, I can add them in any order I like. And then I'm going to say plus. Here I'm going to go back and I'm going to say plus any other term with an even power, which would be the ones that would belong to the cosine expansion. And then we say plus I, factor out an I. So which means this term would simply become omega t. This term here would simply become minus omega t cubed over 3 factorial plus all other terms with odd power, being the ones that belong to the sine sequence. So what I have now is basically the expansion for cosine plus I times the expansion for sine. So I can take that and I can rewrite it as follows. So e to the I omega t is equal to, so this is going to be cosine of omega t, as I showed in part A, plus I times this expansion here, which is sine of omega t, which is what we showed in part A as well. And that proves the identity we were trying to prove. And so this identity is important, and you'll see it a lot in this class, and it's good to know where it comes from. So finally, for part D, we want to prove that the natural log of -1 is equal to I pi. So up until this point, we haven't really dealt with natural logs, but we have dealt with an exponential. And we know that the natural log and the exponential functions are inverses of each other. So if I want to undo this natural log, I can simply take both sides to the power of e. And that's a valid operation. I can raise one side of an equation to a power as long as I do it to the other side as well. So on this side, this e cancels out this natural log, and I end up just with -1 times e to the I pi. Well, e to the I pi looks a whole lot like something we could use this equation for. So if I simply let omega t equal pi, I can write that e to the I pi is also equal to the cosine of pi plus I times the sine of pi. So the cosine of pi is -1 times I, the sine of pi is 0. So that's -1. So we end up with -1 equals -1, which is true. So using that identity we derived in part C, we were able to prove what the natural log of -1 is. So this part of the homework did not involve a lot of complicated math, but it did derive some results and equations that are going to be very important in this class and that you'll use a lot.